Hello everyone, welcome back to my YouTube channel. So in our last video we talked about finding the equation of a line when it is parallel, and we solved one question. So here I have with me two more example questions under equation of a line when it is parallel. So now question 1, write down equation of a straight line which passes through the point. This is the 2 points, the coordinates given, -1 and 3, and has a gradient of 2 units. And then we have our question 2. But then let us solve question 1. Apologies for that. Now for question 1. Now as you can see, this is parallel. And the formula for finding the equation of a line when it is parallel is y minus y1 equals m into bracket x minus x1. So this is the formula for finding the equation of a line when it is parallel. And now let us label the coordinate. This coordinate here, which is -1, will be x1. This coordinate here, which is 3, will be y1. And then the m is the gradient, and the gradient is what? 2 units. So that will be y minus, our y1 is 3. So you write y minus 3 equals, m is the gradient, and the gradient is 2 units. You write 2 into bracket x. Now, x1 is -1. So we have minus here. So that will be this minus here times -1. We are going to have +1. So let's solve. Y minus 3 equals, expand your bracket, you have 2x plus 2. 2 times x, 2x. Then 2 times 1, we have 2. Now you have to make your y stand alone, and that will be y equals 2x plus 2. When -3 comes here, it becomes +3. So y equals 2x plus 5. So this is the equation of a straight line. So I'll be solving question 2. For question 2, we're still using the same formula because it is parallel. That will be y minus y1 equals m into bracket x minus x1. So the coordinate given in this question 2 is -1 and 2. -1 and 2 are 2 coordinates, which will be, so our x1 is -1 and our y1 is 2. So whatever coordinates you are given will be your x1 and y1. So our x1 is -1, our y1 is 2. x1 -1, y1 is 2. So now they said we are not given the gradient, but then we were told the obtain the equation of a straight line which passes through the point -1 and 2, and it is parallel to the line 2x minus 3y equals 5. So this part where it says it is parallel to the line 2x minus 3y equals 5. So this is the point where you are going to get your gradient from. And how do we get the gradient? You have to use the same method that we use in getting gradient and y-intercept. Now, do you remember in our previous video where I talked about how to find gradient and y-intercept when you are given an equation? So look at this equation. We have 2x minus 3y equals 5. Now, how do we get our gradient? Remember, to get your gradient, you have to use this formula, y equals mx plus c, which means y will be standing alone and every other value will be going to the other side. And after doing that, once your y is standing alone, whatever is the coefficient of x will be your gradient, because this m here is the gradient. this c here is the constant and it is called the y-intercept. But then we don't need the y-intercept in this situation. We only need the gradient. So whatever is the coefficient of x, which is m, is going to be our gradient. And to get that, we have to make y stand alone in this equation. So how to make y stand alone? We have 2x minus 3y equals 5. So make y stand alone. That will be minus 3y equals 5 minus 2x. Now divide both sides by minus 3. Divide both sides by minus 3. Then we have minus 3 will cancel minus 3. We have y equals, and then from here, let's factorize from this point. Before we factorize, let us rearrange this part so it won't be confusing. So you bring minus 2x to the position of 5, and you take 5 to the position of minus 2x. That will now be minus 2x. This is plus 5. You bring it to the back, plus 5 over minus 3. Then you factorize. Y equals minus open bracket 2x minus 5 close bracket divided by minus 3. Now if you expand this bracket, you still get this expression back. Minus times 2x minus 2x minus times minus 5 plus 5. So my point is, what we did here is what we call factorization. So now minus we cancel minus. What do we have left? Y equals 2x minus 5 over 3. So from here you segregate it. So they'll be in different places. That will be 2x over 3 minus 5 over 3. Remember I said to get your gradient, whatever is the coefficient of x will be our gradient. Now the coefficient of x here is 2 over 3. So our m, which is our gradient, is 2 over 3. Why? Because the coefficient of x is our gradient. So we have gotten our gradient, we have gotten our x1 and y1. So now we can now solve this question. So y minus y1 equals m into bracket x minus x1. Now the y, now what is y1 in this question? The y1 is 2. So that will be y minus 2 equals, what is the m? The m is the gradient. And what is our gradient? Our gradient is 2 over 3. Remember we solved this equation to get our gradient. That is, from this equation given here, we made y stand alone to get the coefficient of x, which is our gradient. So the m here is 2 over 3 into bracket x. Now what is x1? The x1 here is minus 1. So this minus here multiplied by that minus 1, which is the value of x1, it will give us plus 1. So y minus 2 equals, you have to use this 2 here to expand this bracket. 2 times x, we have 2x, plus 2 times 1, we have 2, over 3. From here, you cross multiply. Then we have, there is no value here, so just put over 1. So here we have 3 into bracket y minus 2. This 3 here will multiply this expression here. So that's 3 into bracket y minus 2 equals, when you use this 1 to multiply everything here, you still get 2x plus 2. So expand this bracket here. We have 3y minus 6 equals 2x plus 2. Remember, to get our equation of a straight line, we have to make y stand alone. So to make y stand alone, take this value here. That will now be 3y equals 2x plus 2. Minus 6 becomes plus 6. Then we have 3y equals 2x plus 8. To get our equation of a straight line, divide both sides by 3. In doing so, you'll be making y stand alone. So 3 will cancel 3. We have y equals 2x plus 8 over 3. And this is the equation of a straight line. So in the next video, I'll be teaching equation of a straight line when it is perpendicular. Thank you.